Hello guys, we're gonna talk about how to retrofit a hydraulic pump and what type of information do we need to retrofit it and why would somebody want to retrofit a hydraulic pump. The main reason to retrofit a hydraulic pump is usually is going to be delivery time. It can be an existing pump may have 5, 10, 20, 25 weeks delivery, and at plant level they may be looking for something more common in the market, something faster, something that they can work with a little bit easier, and have a delivery when they need the components. So many times the main reason is going to be delivery time of the components, delivery time of a hydraulic pump. Another reason that could come into place is cost. Maybe an existing component is too expensive, and maybe they're looking for something that is going to do the same work at a lower price. A little bit less expensive of the components. So usually those are the two main reasons why would somebody wants to retrofit a hydraulic pump. Either they cannot wait for a delivery of the component, or they're looking to save costs, reduce costs on operations. So with that in mind, what kind of information do we need to retrofit a hydraulic pump? um, Main things are going to be pressure, GPM, and RPM. What's the maximum operating pressure in the system? What kind of pressure the pumps needs to deliver? What's the GPM? What GPM the pumps needs to deliver to the system? And what type of RPM is the shaft rotating? Usually, this information can be found in the hydraulic schematic. If you look at the prints, if you look at the circuit, and you go where the pump section is, it usually will tell you the PSI, the GPM, and the RPM. Usually, the RPM at industrial hydraulics for electric motors is usually running at 1800 RPM. And you also need to look at what's the rotation. If it's a clockwise rotation or counterclockwise rotation for the shaft of the pump. When you look at the pump directly to the shaft, if it's rotating clockwise or counterclockwise. With this information, if you have a fixed displacement pump, you don't need anything else. Pretty much you need to deliver flow and pressure at a certain RPM, and that's it. That's all you need to know, and you need to match a component to meet the system requirements. If it is a variable displacement pump, you need to know what type of control is the pump using. Usually, there are the most common controls are three different ones. It's pressure compensated, load sensing, and horsepower limiter. There's more controls, but these are the most common ones. Basically, the pressure compensated control, what it does, it reduce flow from the pump at a certain psi. Let's say the pump is delivering let's say 30 GPM, and let's say that 3000 psi you want to cut the flow, and you want to maintain the pressure. So at a certain psi, the pump reduces flow and it maintains pressure. What it does is it saves horsepower in the system, and it keeps the pump from overheating. Let's say if it would not have a pressure compensated control, usually fixed displacement pumps, they don't have any type of control. And depending on the system, basically what it does is if you keep pumping flow at a high pressure, and the pump is not required to do any work at that pressure, it's not moving a cylinder, it's not turning a motor, so the pump still would deliver flow. And what happened, it would go to a relief valve, and you're dumping high flow through a relief valve for a certain amount of time, and during that time the pump is wasting horsepower. It's wasting horsepower. Horsepower is flow and pressure. If you have high pro and you high flow at a high pressure, you keep wasting all that horsepower and your system overheats. So for that reason, you have a pressure compensator on your pump, and it saves you from overheating the system, and it saves you horsepower. The other control is the load sensing control. Basically, this one is usually goes together with pressure compensated, and what it does is it's normally used when you need a constant velocity during changing loads in your system. Let's say you're extending a cylinder, and during that extension, your load may vary from 1,000 pounds to maybe 500 or 2,000 pounds during that extension, and the pump needs to maintain the same velocity even though the load is changing. So a load sensing, what it does, it just senses the load in the system, and it maintains a certain speed during the changing during the changes of the load. So that is a load sensing control basically. Horsepower limiter, either horsepower is pressure and flow. It either gives you a high flow at a low pressure or a high pressure at a low flow. Or it can give you a combination of both up to a certain point. Let's say you set your pumps to have 30 horsepower. Within that room of those 30 horsepower, the pump is either going to give you high flow with low pressure, or high pressure with low flow, or a combination of both, but it would never go over the 30 horsepower that you set it at. So that is the horsepower limiter control, and basically those are the three type of controls that are more available, or I should say they're more common in the market. And once you know what type of control the pump has, what's the PSI, what's the GPM, and what's the RPM, once you have that information, then you have everything you need to size a pump, or either pump, any type of pump, to match the system requirements. So as long as your pumps can deliver all the characteristics within these requirements, pretty much any pump that is able to provide these components would work for the hydraulic system, and it will meet the hydraulic system requirements. Now, the next step is the physical installation of the pump. Many times at plant levels, people don't always want to do a retrofit. The main reason why they don't is because if you have a pump that is not 100% interchangeable with the one that you already have in the system, many times you may need to change fittings. You may need to maybe move the fittings or the piping or the hoses around the pump. Many times you may need a different coupler to put it in there, and you may need to change a little bit the position of the inlet and the outlets of the pumps. Now, if people at the plant level say, well, changing the hose is not such a big deal, given the case that I may not be able to live with the delivery times of the other pump, given that the case, and say, okay, we may go ahead and change the hosing around, and as long as we have something that works and it's a better delivery time, maybe we will do it. So if that's the case, then they can go ahead and do the retrofit. Another point to keep in mind is going to be the coupler of the pump to the electric motor. Usually there's only, if it's a machine that is made in the US, if a US standard, it's usually going to be an SAE mount or shaft, mount and shaft, and there's only a few styles. There are standards actually. So, and depending of the size of the pump, it could be that they could have the same mount, and it could be also that the same shafts are available. And to find out what type of mount you have, basically all you have to do is measure what is called a pilot. It's basically the circle on the face of the pump. What is the dimension? And it's either going to be 2, 3, 3 1/4, 4, 5, 6 inches, and those are pretty much the SAE mounts. And then the other one is either the same size dimension of the pilot. It's either gonna be a 2-hole or a 4-hole mount, or a 2-bolt or 4-bolt mount. And to confirm it, basically you can measure the diameter between center to center, and you can see the pattern is pretty much the same. So usually for an SAE standard, it's either gonna be a 2-bolt or 4-bolt mount with measure of the same dimensions of the pilot. Sometimes you would have a 6-bolt mount, but when you see those pumps, it's usually a combination of 4 and 2. So it would fit either a 2 or a 4-bolt. Now the same with the shafts. It could be a spline shaft or it could be a key shaft. There's only so many dimensions of the most standards, anyway, the SAE standards. And if you have a standard shaft, it would be better because it's a shaft that is more available. And usually pumps that are made in the US, or machinery that comes from the US or that is located in the US, usually is going to be an SAE standard with pumps and with mounts and shafts. Given the case that, for example, in a given case that you don't have, it could be the frame of the pump to deliver a certain flow. You may have a B mount, but the other pump may have a C mount in order to deliver the same flow. If that's the case, you can also fix it by changing the coupler between the electric motor in the pump. And all you need is the information from the electric motor, and you can also select a different coupler and a different bell housing. Those components are usually pretty quick delivery time, and pricing is not so much for a coupler, and you can go ahead and run the pump. So those type of components are also pretty easy to find. So, and with that, that's pretty much all the information that you need to retrofit a hydraulic pump. You need pressure, flow, RPM, type of control. Then just check out your hosing, check out the mounting of the pump, and that's pretty much it. That's all you need to retrofit a hydraulic pump. And hopefully once you have a new component, you may have a better delivery time, and you may have something that you can work with, and something that there's going to be easier to work at the plant. So that's it. Thank you.